All right, good morning to Calculus 2. We have some requests for me to do some of the sample problems for the test. So we'll give that a shot. So we'll just start with the first one here and see what happens to us. So the first one is we want to figure out the integral from 2 to infinity, okay, of dv over, and we have v squared minus 2v minus 3, and we have to go ahead and sort this out. So I'm going to treat this as an improper integral for the purposes of like just working out the integral, and then we'll deal with the limits at the end. So we're going to do that. So the first thing we're going to deal with is, well, it looks like we have partial fractions. We have dv over, and this looks like a v minus 3 and a v plus 1. And we're going to set that equal to a over v minus 3 plus a b over a v plus 1. So we've got to go ahead and sort out the partial fractions here. So I'm going to go ahead and set it to 1 dv on the other side and just go ahead and figure this out. So we've got a times v plus 1 plus b v minus 3 is equal to, this 1 was going to be over this common denominator here, so it's just going to be equal to 1 when I multiply through the fractions. There's about half a dozen ways to do this, if not more. You can do it the way that you please. If you use the cover-up method, that's fine. If you want to do something a little bit different, that's fine. You don't have to have done it my specific way. So this is the way that I've done it. That's the way I like to do it, but you have your own methods, and it's fine to use other methods to do this. So we're going to go ahead and equate coefficients. So I have AV plus BV. What happens on the other side? Is there any V's over on the right-hand side? No, there is not. And then we're going to have A minus 3B, and that is equal to 1 on the other side there. Okay, I'm going to go ahead and eliminate my a's, so I'm going to multiply everybody by -1. So the system of equations I have is a plus b equals 0, which kind of implies that a equals -b. Over on the other side, I've got -a plus 3b equals -1. All I did was multiply through by -1 to see what's going on here, and that's what we're going to do. Go ahead and use elimination methods. We're just going to add the two equations together. We have 3b plus 1b is equal to 4b equals -1. B will be -1/4. A will then be +1/4. Okay, so going through and going back to my integral here, we have the 1/4 integral. I'm just going to put the 1/4 because it's both of them on the outside here, and we've got 1 over b minus 3 dv. Okay, and b was negative, so we have -1 over v plus 1. Again, we have a dv. We just have to integrate this. And again, realizing I'm working the improper integral before I put my limits in, because I don't want to carry around a limit the entire time. So we end up with 1/4, and then we have times the natural log of v minus 3 minus the natural log of v plus 1. The only thing I did for pre-processing was making sure that the -1 went second, because I'm going to pull this little trick out to say this is 1/4 natural log of v minus 3 over v plus 1. Yeah. And now we're going to go ahead and introduce our limits here. So we're going to say let t equals the limit as v goes off to infinity. And since the limit of a log is the same as the log of a limit, we're going to go ahead and say we need to figure out the natural log of v minus 3 over v plus 1 as we are going from 2 off to t. Remember, t is now my limit. Okay, but if I'm just kind of inspecting this, we could say we're going to get an infinity over an infinity type of situation. Okay, we're just going to get an infinity over infinity here, which means we're going to have to use a L'Hopital's rule. So I'm just going to look at the inside one. We're just going to say, what's the limit of t goes to infinity of t minus 3 over t plus 1. Again, you can use limits inside the log, you can pull them outside of the log, and that's fine. So since we have our infinity over infinity kind of situation here, that's an indeterminate form, we can now use L'Hopital's rule on this thing, meaning we can take the derivative top and bottom. So we're just going to get, let's put this in absolute values here. So we're going to end up with 1 over a 1. So that's going to be 1. So I go back and put it inside the logarithm. Yeah, we're going to have the natural log of 1, okay, after the L'Hopital's rule. So this would have been the limit. Okay, let's go back to this. Use L'Hopital's rule. We're just going to get 1 over 1. So my limit here is equal to 1. Let's put this 1 back inside of the natural log. The natural log of 1, of course, is 0. So I know that the upper limit is just going to be 0 here because the natural log thing going on here. So we're going to take 0 minus, and now we have natural log of, we have v minus 3 over v plus 1, and we're just evaluating it too. We've already evaluated it t was our 0. Let's not forget we have a 1/4 all the way up front here, okay, from way back when. So we have equals 1/4. Now we have 0 minus natural log of, plugging into 2. We have 2 minus 3. Thank goodness for those absolute values, right? And then 2 plus 1. Okay, so we're going to end up with, 1/4 minus 0 minus, okay? And we have natural log of 1, because we have a natural log, we have an absolute value here. So 2 minus 3 is -1, turns into +1. Over 3, this is going to be 1/4. This is, by the way, times negative natural log of 1/3. But we're going to go ahead and pull this little trick of saying this is 1/4 times ln of 3 to the -1 like this. Pull the -1 down in front. So we're going to end up with 1/4 ln 3, and that is going to be what this integral converges to. All right, I'm going to try to do these in small bits because I think listening to small videos might be more helpful than listening to large ones. So I'm going to go ahead and leave us there and say thank you for watching the video. Good luck with the exam, everybody, and I hope this helped.